Good afternoon, students. Welcome back to Fun Scholar classes. In this lecture series, we were discussing regarding acids, bases, and salts. Okay. So, in this chapter, in our first lectures, we have already discussed regarding acids, right? We already got to know that these huge chemical components can be divided into three bigger, huge chemical groups. One such group is acid, another one is base, and another one is salt, right? And each groups are actually related with each other. Some are chemically opposites of it, and some comes out due to the reaction of two groups. Okay, and other than that, we have got to know that there are also several chemical components as well out there which doesn't really fall under any such groups. Okay, so in this chapter we will be learning in detail regarding these three main groups, some of the examples, some of the usage of these things. Okay, and in our real life also these things are very important, right? So in our previous lecture, we have already discussed how acids are really related with our food habits, right? Some particular fruit, we find it sometimes sweet, sometimes sour, right? So whatever we find the taste, that is actually due to the presence of some kind of acids. And in our previous lecture also, we already discussed some of the examples of such acids which we can find in our food, right? So, before going to the next group discussion, which is the bases, let us just remind a little bit regarding the previous classes by watching a simple introductory video. Okay, let's watch it. Let's just have a discussion and let's just have a basic introduction with these three groups. Okay, so we can recall the entire groups again. Okay.
If we are given lemon juice and soap water in two different beakers, we will be able to list the difference between the two. Perhaps the list will begin with the different colors, appearance, and so on. But these are just properties that we can see. Are these the only differences? There are more. Lemon juice tastes very sour. Soap water is slightly bitter. Please don't try to taste it. Just trust me, it tastes slightly bitter. Is this a major difference between the two? Yes. Taste is an important parameter as it takes us to the chemical properties. Why does lemon juice taste sour? And why does soap water taste bitter? Any idea? The answer lies in the nature. Lemon juice is an acid or soap is a base. Do you know what an acid is and what a base is? Let's get to know these terms first and later get into the details. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surfaces is what pops up in our mind. Well, that's kind of true, because acids are known to create a burning effect of whatever comes in contact with them. They can erode the surfaces or burn the skin when they come in contact with it. That's how acids are. The term acid comes from the Latin word acidus, which means sour. Yes, so are all acids sour to taste? Yes, they are. The intensity of sourness may vary in different acids, but the overall taste of acids is always sour. The best examples of substances that contain acids include citrus fruits like orange, lemon, lime, and grapes. Now let's talk about the soap water. What nature does it have? It is basic in nature, which means soap is a base, or in other words, an alkali. What do we mean by this? For now, all we need to know is that the mild bitter tasting compound is called a base. Bases, when added to water, give foam and leave soapy untouched. Bases are exactly opposite to acids. The best examples of bases include baking soda, washing soda, quinine, and many more. about acids and bases in general. Now, can you tell me what will happen if an acid and an alkali, as in a base, come together? Will the solution explode? Will it give an unexpected reaction? Or something else? Well, it is something that we already know. Imagine we mix a strong acid like hydrochloric acid with a strong base like sodium hydroxide. What will be the result then? The reaction yields sodium chloride and water. Sodium chloride is the common salt used by us. So, an acid with a base gives us salt and water. This is a generalized reaction. Salts are the product of reaction between an acid and base. But now tell me one thing. How do we understand whether a compound is acidic or basic? Can we taste it every time? If we are in a solution of concentrated sulfuric acid, how are we supposed to know its nature? It's not possible to bear even a drop of it on your skin. So tasting the solution is to start with the question. So now, how do we say that this is an acidic solution? There has to be a way to figure it out. The solution has to undergo a few tests. The substance used to check whether the compound is acidic or basic is called an indicator. The indicators indicate by changing their colors. Indicators, when added with acids or bases, show a change in color. That is how it becomes convenient for us to find out whether the compound is acidic or basic. But what kind of substances are used as indicators? Next, we will look at the various indicators.
So from this video, we got to know regarding some of the terms, right? So what were those terms? Okay, let's write those down one by one. So in that video, at first they discussed regarding which one? They discussed regarding acids, right? Which we have already discussed with you, right? And then they talked about the bases, and then there is salts, and then they also mentioned one special type of reaction, which is neutralization, right? When acids or bases are reacted together. So what do you think? What can happen? Explosion? Or these two will cancel it out? Well, we will get to know about this when we will be discussing that particular reactions. Okay. And other than that, there is another term which is indicator. Now, indicator of what? Indicator, mostly they are most recognized or popular with the name acid base indicator. It means it indicates. So the name itself implies indicator is any substance that will indicate, right? So that type of indicator will indicate that if the substance that is in question, either it's a acid or a base. Okay? So we have already learned basics regarding acids, right? It is sour in taste, it's coloring in nature, and it is mostly found in the food items. Okay, so what about the bases? What do you think that where can you find the bases? In previous discussion, we got to know about the acids when we went to the kitchen, right? When we opened our vinegar bottle or we cut our fruits, then we got to recognize or got to introduce with some of the acids, right? Even the spinach has some kind of acid. So that is one question that I will leave for you to answer in the comment section. Okay. So, but in our house, where can I see the bases, the examples of bases? Well, in this case, you will definitely be able to find some examples of bases in the kitchen and others in the washroom. Because in the kitchen, you will find something called baking soda. Okay. Yes, that particular white powder which we use to mainly puff our cake or make our pakoras crispy, right? And other than that, there is washing soda as well, which is mostly the name itself implies for the washing and cleansing purpose, right? So those soda are actually examples of bases. So what are those bases? Okay, Washroom page, when we are going to washroom, let's start with the toothpaste itself. The soap, toothpaste, detergents, these all things which are actually we are using for cleaning purpose are does really consist some type of bases. Okay, so when it comes to acids, we got to know, right? It's soury in taste. So what about the bases? Yes, here in this slide, we have our answer, right? Ever wondered what shampoo or toothpaste taste like? It's definitely not snack and you cannot really have a lot of it, right? So whenever just go to the kitchen and take a little bit of baking soda, mix it with water and just try this. Okay, just try to feel the touch. You will feel a little bit of uh, soapy kind of a feeling. Okay, out of that entire solution. Okay, mixture. Okay, and if you taste it a little bit, it will actually taste bitter. Okay, so it is tasting bitter. So the bases are usually taste bitter. Okay, it does not taste sour, it does not taste sweet, but bitter. So guess which one leaves an acrid aftertaste, bitter ground or candy? What do you think is the answer? Definitely this one. Am I wrong? If I'm wrong, please correct me in the comment section. Okay. So, soaps and shampoos are better in taste, right? Usually, we don't taste because we just go there, use it, and just keep it where we got it from, right? But actually, these things taste bitter and slippery. What I told earlier that the baking soda mixture will give you a soapy feeling, right? It will actually give you a slippery when slippery feeling when you will touch it. Okay, so these are some identifying characteristics that there are chances that the substance you are talking about is actually falls under the group bases, right? So bases are the chemical opposites of acids. So they are actually chemical opposites of acids. So whatever we have learned regarding acids, they will show the exactly opposite chemical properties. Okay? Or इसको whenever we will dissolve it or mix some water with particular acid or particular base, we will get to understand the opposite things in a better way. Okay, opposite properties in a better way, because one will provide H plus ion and another one will provide OH minus ion. Okay, we will be discussing those things in our later like upcoming slides. Let's first understand this one. Okay, bases are present in different items. I have already mentioned mostly in the cleaning agents such as the soaps, detergents and shampoos contain different examples of bases. One such very important base is sodium hydroxide or potassium hydroxide. When it comes to metals, we do really like and we do really know this one, the sodium one, right? And the example is saying hydroxide. So what is the symbol of hydroxide is this one, right? Sodium hydroxide. From here you can definitely write the symbol of the formula of potassium hydroxide as well, right? What will be? It will be KOH. Okay, so it is mostly said as caustic soda and this is mostly known as potash soda. Okay, so both of these two are actually very good examples of strong bases. Okay, just like acids, bases also can be determined in two different groups. One is strong bases, another one is weaker bases. Okay, we will be we will be knowing these things in a very detailed way in our upcoming slides. Okay, some other cleaning agents such as window cleaner contain ammonium hydroxide. It also contained ammonium hydroxide, right? Ammonium hydroxide, this is also another example of such base, but these two bases are more stronger than this one. Okay, lime water contains, this is lime water is quite a common substance, right? Even before reading about the acids, bases and salts, we already got to know regarding the lime water, which is, am I wrong or right? I might be wrong. If I am wrong, correct me in the comment section. Okay, this is one particular job you will always have whenever you are watching these videos. Okay, so lime water contains calcium hydroxide and milk of magnesia contains magnesium hydroxide. So what is milk of magnesia? Milk of magnesia is mostly used to mitigate the problems regarding constipation mainly. Okay, so indigestion type of problem also can be mitigated by having a milk of magnesia. ठीक है, milk of magnesia basically क्या होता है? It is a mixture of magnesium hydroxide with water, and that is what is said as milk of magnesia. ठीक है, so this is the formula of milk of magnesia is mostly this one. Okay, so here in these slide we got to know regarding some of the common bases, the example of some common bases which we can find around us in our daily life. One such thing is definitely the caustic soda, right? The another one is the potash soda. Those two are also examples of strong bases, right? And then we have cleaning agents as window cleaner. We have ammonium hydroxide. And then we have the most common one, which is the calcium hydroxide, right? And then we have another life-saving base, which is magnesium, milk of magnesia, which is magnesium hydroxide. Okay, so let's move to the next slide and see. We have already got to know about this, and let's watch it how we are using the ammonium hydroxide, the window cleaner, right? And then here comes the soap or the detergents, which is made up of potassium hydroxide or sodium hydroxide, right? And then there is this lime water, which we have already used in different types of chemistry experiments as well, right? Do you remember कि क्या होता है, what will happen if you mix little carbon dioxide with calcium hydroxide? Which gas, some kind of gas will be evolving, which gas it will evolve, right? Okay, so that question is also there for you guys to answer in the comment section. Other than that, there is definitely milk of magnesia, which is used to mitigate problems regarding constipation and or digestive problems, right? So all of these substances taste bitter due to the presence of the base in them. Okay, due to the presence of the base in them. So sodium carbonate is found in washing soda. Sodium carbonate is found in the washing soda. I have already mentioned that washing powder, in the washing powder also there is base, right? Sodium hydrogen carbonate, which is right, is found in baking soda. Okay, sodium carbonate, maybe this is this. If the formula is wrong, you are the one who will be correcting me. Okay, so sodium hydrogen carbonate is found in the baking soda. So baking soda and washing soda, caustic soda and potash soda, all of these the examples of very familiar base group, right? So strong base and weak base, I have already mentioned, just like the acids, there are like weak acids. Remember the first lecture which we have mentioned that there are organic acids, inorganic acids. So most of the organic acids are weak acids, and usually the inorganic acids are strong acids like the hydrochloric acid, then the sulfuric acid, then the nitric acid, right? And other than there are weak acids like acetic acid, oxalic acid, right? So there is these two groups among the acid. Okay, so here also we can find the strong base and weak base. All the bases can be divided into two groups, which is one group is definitely strong base and weak base. As I have already mentioned, the potassium hydroxide, which is potash soda, sodium hydroxide, which is these two falls under the group of strong base. Okay, so strong base, weak base, strong acid, weak acid. Okay ma'am, these are the bases, these are the acid. Why do we need to learn which one is stronger, which one is weaker? Well, there is another group which is salt, right? There are also different types of salts. So if you don't know if the salt is coming from a weaker acid or a stronger acid, then you will never be able to say that which type of salt you are dealing with. Okay, so that to understand that concept, we must have to learn regarding the strong base and weak bases. Okay, so in weak bases we have calcium hydroxide, which is lime water, ammonium hydroxide, which is used in the cleaning the window, right? Window cleaner is made up of ammonium hydroxide. And then there is magnesium hydroxide, which we got to know which we will find in milk of magnesia, right? And then there is sodium carbonate, which is washing soda, I guess. And then there is sodium hydrogen carbonate, which is baking soda to make our food more crispy, right? Sodium hydroxide is commonly known as caustic soda, that I have already mentioned and shared with you, right? And potassium hydroxide is commonly known as caustic potash. Caustic means corrosive or burning. So from here, we get to understand that when we were dealing with the properties of acid, we really talked and discussed that how acids can be corrosive, right? But here, this caustic itself is saying that these things also can be corrosive. Okay, it can create irritation in your skin, it can corrode your skin. Okay, so the strong bases are also dangerous for daily use. So you must have to follow some of the precautions when you are dealing with such strong bases or acids. So being corrosive is not only common property, is not only unique property of acids. Strong bases also can be proved corrosive, right? Or burning. Okay. Okay, so have you ever heard the term alkali? I think you have, right? In many other in any other chapter or in any other experiment or in any other example, you must have used the term alkali. Okay, so sometimes we find it alkali and bases are the similar thing. Well, it is kind of, but it is not also. So actually alkalis are one kind of basis. Let's discuss this. Let's discuss it in a detailed way. What are the similarities and what are the differences? Why are we using these two distinct terms to identify the base group? Okay. So all alkalis are bases, but all bases are not alkali. Ah, such a poetic line, isn't it? So here it is saying that all alkalis are bases. So there is this umbrella term. Do you know what is umbrella term? Which is the bigger term, in which the short terms will fall under. Okay. So alkali is a short term. So alkali is one type of base basically. Okay. So all alkalis are bases. So alkali group will fall under the base group. But all bases are not alkalis. But it doesn't, there is no guarantee that every type of bases will fall under this shorter group alkali. To understand in better way, we must have to understand what this word alkali actually means. Actually, many bases are insoluble. They do not dissolve in water. But if a base does dissolve in water, we call it alkali. So whatever, which type of bases will make a solution type of mixture with water, we will be calling it as alkali. Okay, let's know regarding the examples. Okay, sodium hydroxide, NaOH, magnesium hydroxide. Obviously, the milk of magnesia is a mixture of water and magnesium hydroxide. I have already mentioned, right? So it is actually soluble. So it is actually alkali. Sodium hydrogen carbonate, which is washing soda, right? Or baking soda, right? So this is the baking soda. Sorry, it was my mistake. It is the baking soda. So this is also soluble in water. So definitely these are alkalis. So let's get to know about now the insoluble bases, which are the copper hydroxide, calcium hydroxide. These are actually insoluble bases. Okay, so we cannot really use the alkali term to denote these bases as they are not soluble in water. Okay, acids and bases, powerful allies, but corrosive force, handled with care. So there we must have to understand this symbol. Okay, if you ever go to the lab or in a medical shop or in a chemical uh, or in an industry factory, there you will be able to see this kind of signs. These signs are actually for your awareness. Okay, this signs denotes that particular thing on which the sign is there, it might contain some type of corrosive acid, either corrosive acid or corrosive bases. So you must have to handle these things with care, right? So because they have corrosive properties. And there are we have already got a basic conception regarding acids, bases, right? So here I have already mentioned that whenever there will be two types of ions, one is H plus ion, another one is OH minus ion, right? So let's discuss and know more about what is the ion and the relationship between the ions and acids and bases. Okay, so acids are those substances which increase the concentration of hydrogen ions, which is H plus. This is basically H plus in water. Think of hydrogen ions as tiny positively charged particles. Acid release these particles into water. Basically, acids are only able to release these particles, which are the H plus ion in the water. So whenever something is releasing H plus ions in the water, then you must know that particular substance is a type of acid. Okay. So when it comes to bases, increase the concentration of hydroxide ion, which is OH minus ion in the water. Hydroxide ions are basically negatively charged particles, and mostly the bases release this into the water. So right now, can you mention some of the differences between acids and bases? थोड़ा सा just think for a while and let me know this answer. Can you mention at least three examples or 3 points where acids are showing opposite properties of the bases, or just three differences between acids and bases from the discussion from the first lecture and till now? Can you mention? थोड़ा सा सोचो, just think for a 5 minutes and then give me an answer. So if we try to study the differences between acids and bases, then we can write that these are usually sour in taste, right? These are bitter in taste, right? We can say this. What do you think? Okay. Then bases usually gives soapy touch, right? But acid will not give soapy touch. And can you think about another difference between acids and bases? One thing, if I use litmus paper, do you know what is litmus paper? Litmus paper is one very popular indicator. What does it indicate? It is actually a acid base indicator. It will change its color. So when it comes to bases, it will change its color like the red litmus paper will become blue, but when it comes to bases, the opposite will happen. The blue litmus paper will change to into red color. Okay, so there are here, some of the opposite properties, and also acid gives H plus ion, and bases gives OH minus ions, right, in water. So here there is pH scale. Okay, pH scale is it might look like a rainbow. Okay, pH scale. So what that particular scale is there? When the name is adding the word scale, then definitely it is something to measure, right? It is used to measure something. So here we are actually measuring the substances property of acidic or basic property by using this scale. Okay, so let's know more about the pH scale. The pH scale is a way to measure how acidic or basic a substance is. It ranges from 0 to 14. Okay, so in this slide we will learn how to rate and understand the pH scale. Okay, so pH scale is basically a scale which will give me a proper understanding that either the substance I'm talking about is acidic or basis. Even if it is acidic, is it a weaker acid or a stronger acid? Same like vice versa when it comes to basic as well. Okay, so in pH scale, you can find different numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And here we have the 14. Okay, from the 0 to 14. So what is the exactly middle point of the pH scale? The middle point of the pH scale is actually 7. And what do you think that it is denoting? It is actually denoting neither acidic nor the basic. It is actually denoting the neutral point. Remember, at the first time when the video was starting, I said, yes, most of the chemical components falls under these groups of acid, bases and salts. But there are definitely some of the elements, some of the chemical compounds which doesn't fall under acid or base group. Okay, those are mainly showing you the neutral magnitude, right? So here as the example can be H2O or pure water, and also can be the blood. Okay, so these are not really acidic or basic, but when it comes to like 0, 1, 2, these are extremely acidic, strong acid, just like the gastric juice. The gastric juice is a highly acidic substance. Why? Because it consists which type of acid? The most strongest acid, hydrochloric acid, right? We have already got to know about it in our previous lecture. And then there is slightly acidic, which will be in the 4, 5, 6. Okay, so the slightly acidic, the fruit juice those can be slightly acidic, right? Then same goes for the slightly basic. Milk of magnesia can show the slightly basic magnitudes, right? Highly basic magnitude is definitely the caustic soda, potash soda, right? So this is how we will be denoting the magnitude of either. From the magnitude we can be understanding, we can be able to understand exactly if the substance is neutral or just acidic or highly acidic or slightly basic or highly basic. Okay, so let's see this magnitude. 0 to 7 are this mostly acidic. Either it's like highly or slightly, it falls under the group of acidic. Okay. So neutral like the pure water are mostly 7 or around 7. Okay. From 7 to 14 are basic or alkaline. Okay. That means the lower the pH, the more acidic is the substance. The lower the pH, the lower will be the magnitude, the more acidic that particular substance is. Okay. And the higher the pH, the more basic is the substance. Okay. Just take a look of this slide, then we will be going to our next slide and we will be discussing regarding the pH scale in detailed manner. Okay, before that, just go through this colorful scale which is called pH scale. Okay. So here we got to know in the video also, the first video that we have watched. In that video also this term indicator came, and I also mentioned regarding the litmus paper, which I also said that this is a popular indicator. An indicator is a dye that changes color when it is put into an acid or a base. An indicator tells us whether the substance we are testing is acidic or basic by changing its color. Okay. Indicators, the colorful detectives that reveal the secrets of acids, bases and salts. Again, a very poetic line, right? So the red litmus paper, when you are putting it in a basic solution, it will change its color. It will become blue. Vice versa to the acidic, for the acidic solution. Okay, but it will not change its color if you are putting it in a neutral substance like pure water, right? So acid based indicators are two types. Basically there is natural indicators and then there are synthetic indicators as well. So before going to the and knowing more about the indicators, let us first know regarding this concept, which is acid and base. Okay, so we have already discussed regarding the acid and we have also discussed regarding the base. Now, what will happen if we mix these two together? When acid and base unite, a salty transformation that packs a punch. So will it be like an explosive reaction? What do you think? What can come out of it? So here it is already written, we will be getting salt and water. We will be getting salt and water. Okay. So let's take a very basic acid, a very strong acid, which is HCl, right? And let's take a very strong base as well, which is sodium hydroxide, right? The caustic potash. What can you get from here? So double decomposition will happen here. Okay, displacement will happen here. We'll get, अगर ये A and B है, if this is C and D, then you will see that these two will come together, then the remaining will come together. Okay. So after the entire reaction occurred, you will get to know that this is NaCl, which is sodium chloride, which is right. And then there is this water, right? So basically, when acid reacts with any types of base, it will always create salt and water. You can say it as it is a 101 rule in chemistry that whenever acid will react with a particular base, it will create one type of salt and water. Sometimes it will evolve one type of gas as well, but sometimes it might not, but always it will create salt and water. And this particular reaction is called as neutralization reaction. Okay, so let's know about neutralization by watching a video.
If we take two solutions, one acidic and the other alkaline, and mix them, what will be the result? By now, you should be able to answer that it will give us a salt and water will be released as a byproduct. Now, does this happen every time? I mean, will an acid and an alkaline always give us salt and water? Yes, it will always be like this. An acid, when combined with a base, will always give us salt and water. And what is this reaction called? Does it have a specific name? Yes, it does. It's called a neutralization reaction. Here, the strength of both the acid and the base are lowered. They are brought to a neutral point where the intensity of the acid as well as the base are dropped lower. The best example to study a neutralization reaction is the formation of sodium chloride, or simply called common salt. If we take hydrochloric acid and combine it with sodium hydroxide, then the neutralization reaction gives us sodium chloride and water is obtained as a byproduct. The reaction also liberates a lot of energy in the form of heat. This is how every neutralization reaction works. Acid and base combine to give salt and water with heat generation. But looking at the reaction of sodium chloride formation, you may say that neutralization only occurs in laboratories. When acids and bases are combined in a test tube in a lab, it's only then a neutralization process occurs. Is that the case? Actually, that's not the case. Neutralization reactions are a part of our daily lives as well. Many reactions occurring inside our body or even throughout the day are neutralization reactions. For example, we usually find elders complaining about acidity or ants biting us on the skin. These are examples where the percentage of acid increases inside or on the body compared to the normal value. Such cases are treated with medicines. But have you wondered how these medications work? Needless to say, they work based on the principle of neutralization. Next, let's have a glance at the various examples of neutralization reactions in everyday life.
So from this video, we got a basic understanding of neutralization reaction. So let's discuss it in a detailed manner. So neutralization reaction. So acid and bases are chemically opposite substances, right? So when they both are mixed together, they are actually cancelling each other out and becoming neutral. So that is why the reaction is called neutralization reaction. Okay. The reaction in which an acid reacts with a base to form salt and water is called neutralization reaction. So itself, you don't have to even remember in a other way. So whatever is happening, that will you be writing, and that is the exact definition of the neutralization reaction. Okay. So the acid and base is mixing and the salt and water is being created. Okay. Some heat is always evolved or produced in a neutralization reaction. So mostly these are exothermic. Okay. So acid plus base is equal to salt and water. This is the basic thing that will be occurring, that we will be finding in each type of neutralization reaction. Okay. So let's discuss it with an example. When sodium hydroxide, which is one very strong base, is treated with hydrochloric acid, again one very strong acid, then a neutralization reaction takes place to form sodium chloride, which is salt and water. This can be written as sodium hydroxide plus hydrochloric acid is equal to sodium chloride plus water, which I have already mentioned while I was discussing the first introduction with the neutralization reaction. Okay. So other than this very common example, there are so many examples in our daily life, from digestive problems to ant sting to acid rain to having soil treatment. We are actually using different types of neutralization reaction in our daily life. So other than this one, can you mention some of the examples and write the chemical reaction of such neutralization reaction in the comment section? Well, in the upcoming lecture, we will be discussing those examples of neutralization reaction, as well as we will be more understand regarding another huge group, which is the salt, which is coming out of this neutralization reaction, its properties, its types, and as well as we will be discussing regarding the indicator, how does it actually works, and which are the main types of indicators, which are the most commonly found indicators, and what color it will change. Okay, in the our upcoming lecture series from this chapter, we will be discussing these interesting topics. Other than that, whatever we have already discussed till now, if you have any doubts regarding this, let me know in the comment section. Thank you for being patient, and let's meet with you in our upcoming video. Thank you.